Greetings, everybody. Welcome to today's webinar, part of the Transforming Data into Digital Assets webinar series presented by Pimsoft. I am Ryan Bolin, your moderator, and we thank you for joining us and hope you find this webinar informative and valuable. Today, we want to demonstrate Pimsoft's structured modeling approach to eliminate imbalance with production reports, reduce uncertainty in inventory estimation and valuation, while adhering to the international corporate governance protocols, including SOX compliance in the US, King 3 code in South Africa, and Combined code in the UK. In this webinar, you will learn why Sigmafine is used in mines and metals, how a model-based approach can validate and improve measurement and simulated data, and how Sigmafine helps corporations adhere to compliance. Thank you for your attention. Now it's my great pleasure to introduce our presenter for today, Felicia Moody, Pimsoft's Industry Principal for Mines and Metals. Felicia?
Thank you, Ryan, for the introduction, and let me give you sincere thanks for joining us this afternoon on our first webinar in metals and mining. If you don't know our story, the Pimsoft story is that this is our mission, this is our reason for existence. We improve the accuracy and the reliability and the usability of your process data. And when we do that, we make it available to the entire enterprise. And in the past, you may know us as a data reconciliation company, but our infrastructure has grown significantly where we can bring the data beyond the context of reconciliation and bring it into the context of an enterprise solution. Our story started many years ago. Sigmafine is the product and Pimsoft is the company. Sigmafine's story started in 1993 with KBC. It was acquired by OSI Soft, and then it was sold. The product Sigmafine became a property of Pimsoft in 2000. Since then, we grow the product, we keep it compliant with the OSI platform, and we also are growing geographically. We have an office in India, and we're growing on the technology side. We acquired Omicron, which is an advanced Pi service company. Why do we do a mass and component balance? These are three possible reasons why you are doing it. You need to. There's a SOX, there are rules to operate in each country, in each continent. There's one for the UK, there's one for AMIRA, which is metals and mining. We have King's Code, we have another code in South Africa. So you might just need to do it. And one of the primary output is your financial records need to be accredited, it needs to be validated. Another interesting area, especially metals and mining, is now the metals and mining industry is quite segmented. It's not like in the past where the owner of the mines was the owner of the refinery and was the owner of the finished product, the smelters and the finishing products. Each step can be separate entity. And therefore, the transfer of material needs to be monetized. And when it needs to be monetized, it should be pretty accurate, or at least the inaccuracy and variability should be known. Another key factor of doing mass and component balance is your emissions and losses. In the past, probably you could just declare what a flow meter is saying, but sometimes your losses are not directly measured. They are things that you cannot find, and therefore it can grow significantly if all of your errors are going to be declared as loss. And this can cause a big penalty, and it can even cause fines, etc. So it wouldn't be a good place to place everything that you cannot find as a loss or an emission. And so these are probably reasons why you are doing it, and let's see if Sigmafine could do it any better. So why do we think Sigmafine can do this job any better? Why? Because we can make it accurate, timely, and contextualized. You now have your data source. It's coming different time, different frequency, and you go to a data lake. Your data lake can be an OSI solution, Honeywell, IP21, a PhD, no problem. Your data lake it's storing a lot of things that you don't even want. It might have missing data spike, bias, but it's being collected. And that data is timely available. How accurate is it? Is it contextualized per day? No. Is it contextualized per asset? Not really. When you put Sigmafine as a data conditioning layer, it conditions the data both on a time series. So all these missing data and spikes and biases can be determined. And the asset is contextualized in terms of an asset. So all the relevant signals towards asset is gathered into the attributes of this asset, so we know how the asset is performing on a timely basis. What does that look like for Sigmafine? When you run Sigmafine, we're not just looking at your process data. Your process data, of course, it's what we need. We need your lab data, your meters, your inventories. But another important part of your data set is what is it you planned to make? What is your scheduling system? How, does your production relate to your utilities and your consumption? We can do mass and energy. We can combine the process side and the utilities side. Maybe sometimes your measures and your measurements are not reliable, and you actually know the performance of your plant based on the chemicals consumption and the catalyst that you're using, or the operating conditions, solubility, equilibrium. Can we use that information to be incorporated in the mass and energy or mass and component balance? Yes. And another important part of Sigma Fine is the receipts and shipment, things you buy and things you sell. They are the boundaries of our model, and those are our zero tolerance data source if we want them to be, and they impact significantly on the balance. So, what Sigmafine is doing, it is collecting a different data source, different structures of data, and different types of data. And on that collected data set, it's applying, in this case, mass and component balance. Let's look at the corporate governance. If you look at the SOX, it is talking about the accuracy of the financial records, and the responsibility rests at the CEO and the CFO. The penalties can reach up to 20 years for the C-level people. The accountant who is in breach has penalties up to 10 years. So here we're seeing that very senior people can be penalized with up to 20 years in prison for the accuracy of the data. The Amiri code, there are 10 pillars, let's say. The last four are shown here, or segments thereof. And it's talking about the data quality, the variability of the data, verification, accuracy, losses, and to eliminate bias. So it's quite specific what the metals and mining wants. The combined code in the UK, it's similar to the stocks, and it's just saying you need to provide good data at all time. And if there is a failure of providing good data, the board and directors are liable at law. So, what are you liable for? You need to have good data. What kind of data are you liable for? You can go to prison for what? Bulk density, an important number to get any mass balance. It has a natural variability of 20%. Your inventory based on mass measurement, it has a limit of about 5% because it uses the bulk density, which has 20% variability. Your mass meters depends on what they're measuring, where they're located. On your feed, it's kind of 1 to 2%. On your mat day, which is in your smelting area, it's like 0.5. Online analyzers, I couldn't find a number to tell you, but every day is different with your analyzer. It depends on its location, on the installation, on the maintenance. It's just it's highly variable. And your moisture, it between you have about 1% variation in sampling. So on one regard, you're liable to have good data, reliable data, but trustable data. And on the other hand, in a metals and mining context, this variability, this inherent uncertainty is rather high. How can Sigmafine bridge the gap between the high uncertainty on the ground level and yet the high level of certainty that's required in the financial records? What Sigmafine does, how do we condition the data? On the left, you see that we can do validation. It's a conditioning. On each data point, we can filter, we can aggregate, we can replace, we can do gross error checks, okay? On a model, on a structured data, we can look when we connect all the data to tell one story between the inputs, the outputs, and the changes in inventories and your losses. We can, when the data is connected, we can then constrain the data to balance on a mass and a component basis, applying physical conservation principles. And when we do validation on a data source and reconciliation on a structured model, what we are doing, we're reducing the inaccuracy of the data. We're removing random errors, and we're identifying gross errors. And once that is done, you will have a data set that is trustable, and should have a reduction in the uncertainty in this new balanced data set. Let's take a look at Sigmafine mass and component balance. How do we do it? The Sigmafine, it's a server and it comes with many analysis. We have mass, volume, energy, component, mass and component. We have material tracking with quality tracking. Today we're going to talk about the component balance. If you're interested to see mass, material tracking or quality tracking, have a look at our webinar series. We've done a couple on those. So in the component balance, we're balancing both the mass and then we're balancing each component that we choose. It does not need to be, and all the components do not need to be balanced. You can select 2 or 3 components that are related to 30% of the mass, okay? How do we do the reconciliation? We need a periodicity. It's a balance. We need a time frame and a start and an end. It's normally daily, but it can be hourly. For those who are Pi customers, we are natively integrated with OSI Soft. There is no connection required. For those who are not Pi, if you're IP21 PhD, we have out of the box connectors that can get the data from your historian, your data infrastructure to Sigmafine and back. The component balance in the structured model can be turned on or off as needed. So you turn on your component balance in areas that you have measurements. In areas where you don't have measurements, you can simply do the mass balance. And then we run the mass and the component balance simultaneously. So here you can see we are trying to minimize the errors both on the mass and on each named component. Our input data is always your measurements and on your mass basis and your components, but we also need your confidence in both the measured mass as well as the analyzer. On the output data, we are giving you the reconciled mass, total mass, we're giving the reconciled component, and we're also going to give you the reconciled tolerance on these numbers. So you will know how confident you should be in the numbers that we have created. Beyond this, we also give you a solvability of areas of the model, and in areas where it is redundant, we can give you statistical index on the goodness of it. When it is solvable, it's a trivial solution, and if it is not solvable, that area of the model is turned off for that period of time. In our case, in mass and component balance, we can do linear or nonlinear. We normally do nonlinear, so we are running both. So you can say I want to do mass then component, or you can do mass and component. We normally do the nonlinear. As I said before, you can turn on or off the component balance, and we can also handle reactions, and we can handle unmeasured components. So we do not need you to add all the components to one. So you can have fractions of the components that are measured and the others are unmeasured. It's not restricted, but it can be flagged to make it force. We can force the solution to one. So this is explaining as I just said. So here I'm going to show you some screenshots from our standard demo for metals and mining. And here our demo is related to the a flotation plant, which is concentrating both copper and gold. It has one feed and it's got 3 outputs, 2 concentrate and a tail, the waste. And there are many process units between the input and creating these outputs. We have the float cleaner, we have the rougher stage scavenger, and these cleaners at the bottom. And for us, just to give you an idea of what we call elements in Sigmafine, we've got mass meters. They are here. They are the assets for us. Analyzers are here. We have some unmeasured flows. Not everything needs to be measured. You can see a few unmeasured flows in the model. We can handle it. It means that area is probably solvable but not redundant, so it's a trivial solution. We have nodes and processes. This would be a node. It's where meters, it is where flows meet or break. So you can see here one flow splits into 2. And we have cases where, 2, 3 flows, they merge and they go out, they join. We have boundary elements. Normally they can be fiscal. For example, if you're buying the raw material, this is a fiscal flow from your financial system. And what you sell can also be a fiscal. It's a number that has been signed off by 2 parties. There are boundary elements, and we call them receipts if they're inputs, shipments if they go out. And just to, as I said before, our component balance flag is optional. You turn it on where you have measurements. So when you have mass and component, you perform a mass and component balance. When you have only mass in that area, you do only a mass balance. Let's take a quick look at a result of one case. We're going to look at the first object, the first tank, which is our flash float cleaner vessel. And here we see that it has one feed and it has a flash concentrate going out, and we have a flow to the rougher circuit. Yeah, this is the feed, the concentrate, and this is going to the circuit downstream to try to recover more copper and gold. If you were to bring these numbers into Excel, you would see that we have an imbalance, a total imbalance on mass of 1 ton. If you, however, look at the copper, the imbalance is at 16 tons, okay? Not good enough. When you run in Sigmafine a mass and component balance, we are trying to minimize the errors both on the total mass and on each component. When the reconciliation runs, we give you not just the reconciled component, but we give you the reconciled tolerance. You know how confident we are in this number. In the results here, if you were to do the balance on the copper, for this case, you would see that both the total mass and the copper imbalance was eliminated. The data that Sigmafine creates, data set is readily available in our AF infrastructure. It can also be exposed to Excel. This is a screenshot of our Excel. And by just bringing the data in Excel, you can see globally, let's say, on overall what happened on that day. This is a daily balance. The upper screenshot here is of our measured data. If you look only on your measured data, you have an imbalance of 20 tons. What is the impact of this 19 tons on your recovery? It is saying that your gold recovery is 70% and your copper recovery is 72%. Your uncertainty is almost 8% on your gold and about 5% on your copper. If you go to the lower screenshot, this is taken from our reconciled data. And you can see that the imbalance is eliminated on the mass basis and minimized on the component basis. Importantly, you should see here that the recovery changed quite significantly. And also, more importantly, because it can go up and down, but let's say the confidence in these numbers, the variation in these numbers has been reduced. You can see that your variation was 6.7%, that has been reduced to 6.4. And on your copper side, the uncertainty has moved from 5 to 2.7. So when you do the reconciliation, not only do you eliminate imbalance, but you get a quantification of what is the certainty of your measured data, as well as what is the uncertainty on your reconciled data. And this is where the compliancy with regards to the corporate governance comes into place. Because not only do we provide you the reconciled mass, but we also give you the confidence in this data set. Once let's say the mass has been eliminated, the error in the mass has been eliminated, you can then use your reconciled mass to create an estimation of your water balance, let's say, which is an important KPI. What is your water consumption, ton per ton, of the feed that you're processing? This is probably something you need to declare daily to the government at the end of the month. And perhaps you have a price based on your consumption. The lower the consumption, the lower the price, and probably even the lower the unit cost of your water. What we're showing here, again, because we're time context, it is a date, it's one day. We are using the reconciled mass, and we're using your measured solids to estimate the water that is used for it on a daily basis. And we know that the water sometimes is not directly measured because it is just a bore in the ground. In that model, in our demo model, we were looking into the details of a beneficiation plant. I have here just to show you that we can also look at the full value chain of Mecklerton mining. Here you can see it is being aggregated on a time frame. We are doing monthly in this case. And here you can see that you're monitoring the imbalance in a process area. We're looking at the concentrator plant as one object, not each tank. We're looking at the pretreatment, the filtration concentrate, tailings. We can also do a deep dive in each area. Again, this is a monthly balance. And here you can then see which area in which process unit is causing you, which is causing the day, which is contributing the most. Again, it is color coordinated. We have the ADA that does it, that color codes the object based on the imbalance, can be based on the test one statistical index of Sigmafine, or it can be based on an absolute value. It is configurable. So my message here is that you can see the data contextualized in areas, you can see it contextualized in assets, you can see it contextualized on a daily basis, on a monthly basis. So this is why we say we condition the data, because we bring the data into focus on, in this case, mass and components. I took this just to give an idea of the magnitude of the problem at hand. And one of the problems, if you remember this on the first slide, we talk about toll treatment contracts. Here I take the opportunity to give you this data set, but from a trading partner, and they made it publicly available. And you can see they sampled 9 batches, and in all 9 batches, both the wet basis and the dry basis of the concentrator producing company is biased in their favor. So the receiver is always on the losing end, because in this case the material is drying out, so the total mass is going down. So you have a real loss of water. Okay, you also have a sampling issue, because on the concentrators producing company, they are creating the sample is agitated, so their percent solids is higher because it is agitated. If it is being dispatched, for overnight or 3 hours, the agitation is not good, it settles. Okay, when they do a dip analysis on the other side, they have a lower mass, but they have a lower percent solid, so their sample is just not reliable. And so we have this difference. So how do they solve the solution? How do you arrive at a solution today without a reconciliation software that is considering both sampling on the receiver and the sender? Maybe it is a negotiating process where you negotiate a value, or maybe you just say it's in the middle. And what we're saying with Sigmafine, we can consider the data set at the source and saying it is more reliable. We can also take the data set of the receiver and say it is less reliable. But both samples can be considered, and value can be reconciled and made publicly available to both parties, so they know the process of validation. So what we're saying is that you now have your measurement device, you probably have your simulation models. We strongly suggest that you send your simulation data to your historian, for example, your PI. And what we're asking to make the Sigmafine improve the data in a step change, we ask that the financial transactions that relate to the purchase and sales of materials be incorporated into the model. Once Sigmafine has your measurements, as well as your simulated data and your financial data, with this robust set of information, we can improve the data quality. We can give you data quality indicators, we can give you reconciled data. Normally, we push this data back to a historian. It can be a PI, it can be Honeywell, it can be IP21. And with this data set, with this workflow, we have seen that teams are able to do much more with a lot less. So they save on the time of the resource, or the resource can do their balance and something else. It can be a process engineer that is inheriting the mass and component balance in conjunction with their daily jobs, because this workflow facilitates, let's say, the balance to be incorporated into a role. It doesn't need to be an individualized activity. If I could give you an overview of where we think Sigmafine, where we know Sigmafine has brought values, is we have improved, not just in metals and mining, but in chemicals, in pharma, in power, in many industries. We have improved the accuracy of production data. And we've increased the model robustness to include losses and emissions, so that the reported loss and emissions are validated. One of the first things that we always find in a project is we find very quickly which errors, which meters are giving significant errors. And so often, one of the first things of a Sigmafine project is that instrumentation gets a very big list of what needs to be fixed and some urgency. On our more advanced customers, not only they're looking for errors and losses, they're now looking, okay, we look into the future. How well did we do today compared to what we planned to do today? So we have done many projects where our planned data or scheduled data is coming into Sigmafine. The difference is being monitored and being used to plan for the next day, uh, not just the planned number, what you need to make based on the numbers you made today, but also to send back to production so they know what they need to. The new targets for tomorrow is based not just on the difference in the plan, but considering the changes in the reconciliation results. And one of the most important part for those who don't know Sigmafine is that every action taken on the data is tracked by the Sigmafine solution. So if you are modifying a measurement data, you're making an adjustment. The measurement data stays as is. The adjustment that you made is recorded at the time and the user and the reason. When a balance is run and is accepted by the team, the mass and component balance can be locked and signed off, so no changes are made. So you can also, Sigmafine also track changes being made on the structure of the model. So if you had an equation calculating a percent solids and you changed it, this change in the configuration of the model of an asset is monitored. We can also do versioning of the model. So today you have one tank, tomorrow you have two tanks. We can have version one. So all the cases which relate to version one relates to the case of one tank, and all the version two, and all the cases related to version two are different. And this association of models of cases to a version is also a capability of Sigmafine. And with these inherent features of traceability and trackability of the Sigmafine infrastructure, and the fact that we give you statistical indices or monitoring or the results of the reconciliation locally on each measurement point or on each balance point, as well as on the model itself, on the global model. So you get three levels of statistical indicators: locally, balance point, and the global model. And with the monitoring of the assets, the quality of the data, and with the auditability trail of the actions taken on the data, Sigmafine in many cases has been the solution to be compliant to the SOX. I read an article to let you know how expensive it can be to put in a compliance program for SOX. The SOX in America has costed over 250 billion for all the companies that have put in a solution to be SOX compliant. And what we're saying here is that if you use Sigmafine for your production accounting, it can account for more than 50% of your infrastructure, also for your SOX compliance. So it doesn't have, you say being compliant doesn't have to be a monster. You can use Sigmafine to do two jobs: to do your production accounting and to do it in such a way that you're meeting your corporate governance requirement. So thank you for listening to me, and I hope that you have seen, you've heard our story as to how we can incorporate all your data set, your measurements, your simulation, as well as your financial data to give you a more accurate data set. I've showed you in the Excel slides in screenshots that you are able to, we monitor locally the data quality on the reconciled measurements. We monitor the imbalance on nodes and tanks. And we also give you the data quality for each component. And we are able, because we are also, Sigmafine is an infrastructure, and we can share data with third party, with our business partners. We can connect and share data so that the boundary of your balance does not need to be the boundary of your facility. Your boundary can extend to an interface to collect data of who's buying and who's selling. And this can help address the situation that often arise in toll treatment contracts. Thank you for listening.
Thank you for this great presentation, Felicia. On behalf of all the participants in Pimsoft, we thank you for taking the time to participate in our webinar and share your knowledge. Anyone interested to continue the discussion on data conditioning can contact Felicia at the email provided. We thank you all for attending. Anyone having any questions or would like to see a demo further, please contact Felicia at the email provided. Also, don't forget to check out our website to see of any other webinars that'll be coming up. We thank you for your time.